Hello folks, this is Tom from anti-proton.com, and I get a lot of emails from people. I mean, just all the time emails from people, and I get a lot of the same kind of questions, so I try to group them up together and answer them kind of quickly. Before I get into anything, let me just simply say the fact that you haven't seen a lot from me recently is because I've been working to death. That's the problem with doing what I do for a living. Sometimes I get sent off to places to do various random, strange things. Anyway, I'm going to be increasing my vacation for the rest of the year to try to bleed off all that extra vacation that I've saved up that I haven't taken, and that will give me time to do more. I'm also buying a nice big house, and one of the key features of my house is going to be my nuclear physics lab that I'm going to be building in the house. Why? Because we all need a nuclear physics lab in our house. Anyway, the things I'm going to discuss today are first, those rad pills, Rad-X, whatever the heck they call it. I can't remember the brand, but the potassium iodine pills that you see, the anti-radiation pills. I'm going to discuss electronics and emission of radiation. Can Geiger counters detect trace amounts of contamination? Is it dangerous to hold small check sources, small uranium samples, that sort of thing, and radiation sickness and the minimum limits for that? I'm going to actually try to boil this down to just 4 or 5 minutes because I'm actually not trying to go into detailed, deep analysis of all these subjects, just to answer them, because I get these exact questions. People ask these questions of me all the time, and I figured I would answer them in one shot. So let's start off. I can, back up anything I'm saying. This is reasonably common knowledge in the scientific community, although I should point out that I am a lay person. I don't want anybody to hear that previous comment and think that I'm trying to claim that I am a computer scientist, but that I'm a nuclear physicist or something, which I am not. I am a lay person as far as nuclear physics is concerned, or any physics for that matter. Anyhow, potassium iodine pills, they do not block radiation. That is not what they do. Your thyroid right in here just loves iodine. If you give it iodine, it sucks it right up, and it's supposed to. There's various important reasons for it to do that. The problem is that after a nuclear accident, like a nuclear bomb or a Fukushima sort of thing, a meltdown, Chernobyl, whatnot, if it's involved nuclear fission of very, very heavy nuclei, you're going to probably have radioactive iodine. There's various isotopes of it floating around, as well as everything else for that matter. Cesium and strontium and all those other things are going to be floating around too. But iodine, your body just sucks it right up like that. And the problem is that radioactive iodine gets sucked up the way it should be, except that it's radioactive, and it goes right into your thyroid. And then it, irradiates you from the inside, and as you probably heard before, that internal exposure is where all the bad comes from. External exposure is bad too, but it's orders of magnitude worse to be inside of you than outside of you. And so, when you eat a potassium iodine pill, what it does is it saturates your body with so much megadose of iodine that your thyroid doesn't want to eat up any. So when you are exposed to radioactive iodine, you don't absorb it very much, and you reduce the amount of exposure you get. That's all they do. From all of these nuclear events, the radioactive iodine is usually gone within 50 or 60 days at the worst. So put it to you like this. Even if the conspiracy theorists were correct and the world is just dripping with Fukushima fallout and we're all on the end of the, at the edge of the world and life as we know it will be over, which isn't true, by the way, but let's just say we're completely true. It's just raining everywhere. You still wouldn't need the radiation pills because it's too late. They would have only been good for the first probably 2 months after Fukushima, and for that matter, they would have only really been of any major effect for somebody who was actually living there. And if you read the manufacturer's labels, they usually tell you that too, because they were never designed for that. They were designed for people right on ground zero after a nuclear event. So please don't, eat those things and think that they're going to save you from, I don't know, whatever random thing you think they're going to save you from. Pills, like all medicines, have specific usage. Consult your doctor. That's the best thing. Consult your doctor and see what they say. Because I'm not a doctor and neither are you. Well, you could be a doctor, and if you are a doctor, tell people. Come on now, don't be silent. All right, now as for electronics and radiation. Often you hear people say that electronics emit radiation, right? See, here's an electronic, it therefore emits radiation. Yes, it does, but it does not emit nuclear radiation, like cesium-137, uranium-238, and so on, those all emit nuclear radiation. Electronics do not emit nuclear radiation for the most part. That was weird. My screen blacked out on me. They emit electromagnetic radiation, just like lights from a light are emitting photons that are light radiation, if you like. Electromagnetic radiation may or may not be harmful for you. There's research both ways on it, and I'm not going to get into a debate as to whether it's harmful or not for you, nor am I saying that it is or is not harmful. I'm saying there's evidence either way. But all I'm trying to say is that electronic radiation, electromagnetic radiation, is different from, is a completely different creature than nuclear radiation. So regardless of whether it is or is not harmful, it is a different thing is all I'm trying to say. It isn't always different from nuclear radiation. They're two different things. So don't mix them up in your mind. Completely different things. Geiger counters, for example, cannot detect the radiation from electronic devices. Can Geiger counters detect trace levels of contamination? People email me all the time. I've actually gotten 2 people recently emailing me about this. If you, let's say, bought something from Japan, you buy this book from Japan, and you want to know whether or not it has radioactive contamination. Well, the answer is yes, a Geiger counter does detect trace contamination, but it boils down to how much can it detect. It's not that it can't do it or that it can do it, it's how much can it do. So what it means is that you could get something that's heavily contaminated, and the Geiger counter could detect it, but you could get something that's very lightly contaminated, and the Geiger counter may not detect it. So that's one of those really hard ones to answer when people say, can it do it? Well, yes, but how much? When it comes to things like food, of course, Geiger counters are not very useful. They're very useful for people who are, like, let's say, in Fukushima. If you have some food and it's all the food you have, and you want to test whether or not it's dangerous, they're useful. Yeah, you could be getting reasonably high levels of radiation as you eat that food, but the Geiger counter can't detect those. What it can tell you is if it's just ludicrously radioactive, and that's basically better than nothing. You know what I mean? It's better than nothing. It's kind of like if you boil your water, if you take a puddle of water and you boil it, you're going to make it reasonably safe by killing the bacteria and everything. You know that there could be lead and other stuff in there, but if that's the only water you have to drink, it's better than nothing. Whereas if you live over in a different country and you don't have that immediate problem, then it's better to let your local water treatment place work on it, because they're probably going to do a better job. And even if stuff gets through, it's going to be a hell of a lot less than would get through if you did it. So the answer is yes, Geiger counters can detect trace radiation that are on things, but no, they cannot detect very, very, very low trace radiation. Maybe, I don't know what their cutoff is. I need to experimentally determine that, but maybe, let's say, a couple hundred becquerels per kilogram. Less than that, they're not going to get it. So, I mean, my powerful polymaster can't go down less than 160-something becquerels per liter of cesium-137 in water. So that's the answer to that. Hopefully you can, yes, but you won't get it all. Is holding a check source dangerous? Well, those little check sources that I hold in my hand sometimes when I'm showing you guys stuff, those little check sources, they make the Geiger counter squeal, you know, and they're all powerful and dangerous looking. The answer is no, they're not particularly dangerous. There is a risk. All radiation carries with it an intrinsic risk of cancer, and that's been established by the international scientific communities and is very much well noted in the BIR 7 Phase 2 report. They even draw some risk to dose relationships, which I'm not going to get into because I am not a health physicist and not qualified to say what those exact relations are, although they are documented, and I do personally believe I know what they are, but I'm not going to get into it here because that's not really something I should do. But they hold a risk, yes, but I mean, that's kind of like saying everything holds a risk. Eating a steak holds a risk. I could die of a heart attack tomorrow, right? So they're not necessarily equivalent risks, by the way. But I figured I would look at it like this. One cesium-137 check source versus one common commercial smoke alarm, a fresh brand new one that hasn't had a lot of time to build up neptunium-237 in it yet, so it's just a fresh new one. The average smoke alarm has a 33,300 decays per second. The average one of my little check sources for cesium-137 is 37,000, so they're almost equal in decays per second. But what we need to really look at is X-rays and gamma rays coming out, because all the beta and alpha for the americium-241 and the smoke alarm for that matter, they're not coming out of the containers very far or very much at all. So looking at just photons, the average smoke alarm is going to produce, I calculated this morning, about 26,781 photons per second, all directions. That little check source, 33,544. That's nearly the same. And to mathematically tell you what the difference is, 781 divided by 33,544. So the smoke alarm is only putting out 79.83% as much as the cesium-137 sample, but that's 79, that's almost 80%. That means that the smoke alarm is 80% as many photons coming out of it as the cesium-137 sample. Now the dose rate's higher than the cesium-137 because it has higher energy, but what I'm trying to say is that even off by one order of magnitude, those two of them are reasonably close to one another. So yeah, they're dangerous, but they're not terribly. I'm not going to like drop dead or something from holding it. And my cancer risk is marginal, to say the least, and that is backed by the BIR7 phase 2 report, I might add. Last but not least, radiation sickness. People, every single time I hold something, this is not a uranium sample, but if this were a uranium sample and I held it, somebody would immediately email me and say, aren't you going to get radiation sickness from that? Or, if you go to the doctor and get an x-ray, aren't you going to get radiation? No, you're not going to get radiation sickness from this. You can be exposed to a large amount of radiation, enough to significantly increase your cancer risk, like a really nasty dose, and not get radiation sickness. Radiation sickness requires a very, very specific amount of sudden exposure. I wrote it down right here. Typically 1 to 2 grays of radiation. 1 to 2 grays of radiation within about an hour or so will give a fair number of people radiation sickness. If you increase that rate, of course, the amount increases. To put it in perspective, to take the lowest level of where radiation sickness really starts to appear statistically is about 1 gray in 1 hour. Now, if I were to take that amount and compare it to one of my check sources, which is 37 kilobecquerels, is how much activity it has, and compare its dose rate, I would say that the dose rate on that, it's approximately 12 1/millionths less. What that means is that check source I'm holding in my hand is providing me a dose in 1 hour that is 83,333 times lower than would require for the minimum for radiation sickness. 83,000. That is 1, 2, 3, 5 orders of magnitude, I believe. So how about them apples? Anyway, so those are the answers to a few questions. And oh look, I went to 12 minutes because I just talk forever. So there you go. Some quick answers to a few quick questions. Hopefully that helps. And I'm